All right, so we're going to talk about simplifying expressions and solving equations. So they're two very different things, somewhat related, but very different, and it's important that you understand the difference between the two. Again, I'm not going to read the entire paragraph to you, but basically the idea here is that in mathematics is kind of like a language, really, and we use specific terms to mean specific things, and it's really important that we get our terminology correct. So I want to talk about expressions versus equations, and I want to talk about simplifying something versus solving something. That's what we're going to cover in this section. Pretty straightforward, but a really important distinction. An expression is a collection of terms, maybe just one term, that may or may not have operations like plus, minus, times, divide. You can have numbers, variables, exponents in an expression, but there is no equal sign. Okay, so we talked about expressions in the last section. They're things like, 2x plus 3, or that's a 3, or -7, or 4x squared plus 5. Like, they have things, numbers and variables in them, but they do not have an equation. If you have an equation, if you have an equal sign, they don't have an equal sign. If you have an equal sign, you're dealing with an equation, okay? And so an equation, let's talk about that. An equation, most people don't know this, and this is really important. It's actually a statement that two expressions are equal in value, okay? It has to have an equal sign, and it must have an expression on the left and an expression on the right, okay? So an equation is actually a statement that, hey, this thing on the left here is actually equal to this thing on the right, okay? So for example, 2x plus 1 equals 9. This is an equation. It is saying that 2 times some unknown number plus 1 is 9, okay? And then you can figure out what the unknown number is. This is what we call solving equations, is figuring out the number for x there that would make this true, okay? 2x plus 1 is an expression. That is an expression. That 9 is an expression. And the equation is the statement that 2x plus 1 is actually equal to 9, okay? So this entire thing is an equation. The thing on the left is an expression. The thing on the right is an expression. And what an equation does is it's a statement that two expressions, the one on the left and the one on the right, are equal in value. So like whatever this is as a number, it is 9, okay? And that's really, really important, because throughout the year, students come up and they're like, oh, well, I solved this expression. And I'm like, you can't solve an expression. You can only simplify expressions, right? Like, you can't solve 2x plus 3. Solving means you're finding a value for x that makes it true. 2x plus 3 isn't true or false. It's just 2x plus 3. But to say 2x plus 1 is equal to 9, that is a statement. And there is a number that you could throw in where this x is, right? 2 times something plus 1 would give you 9. What is it, 4, right? 2 times 4 would give you 8, plus 1 gives you 9. You could solve this. You cannot simplify this. There's nothing to simplify here. You can only solve. Okay, so that's really important. We'll do some examples so you'll see what we're talking about a little more here. Okay, so some examples of equations. Okay, so this is an equation. Very basic. It's saying this expression, 2 plus 4, is 6, and that's true. Okay, so this is an equation. My favorite thing is when we go over to this thing right here, I ask, is this an equation? And people look at me like indignant, and they're like, no, this is not an equation. And I'm like, really? Because it kind of looks like one to me. It's saying 3 plus 5 is equal to 9. Now, this is definitely an equation, and it's definitely false, okay? So, but you can be both. You can be an equation that's not true. Just in the same way that somebody can say something that's not true, right? Like if somebody says something, you're like, was that a statement? And it's like, well, of course it was a statement. Is it true? Absolutely not, right? You can also have statements that are true. And remember, that's what an equation is. It is a statement about whether, about two things being equal, okay? This is an equation. It is definitely false, okay, right? Because 3 plus 5 is 8, not 9. Okay, here's an equation. It has a variable in it. 2x plus 3 equals 11. That is an equation. Is it true? I don't know. It's kind of hard to say because I don't know what x is, right? If you told me x was 1,000, then it's definitely false. It's an equation still, but it's false, right? 2 times 1,000 plus 3 is definitely not 11. But if you pick just the right number to go in where x is, like 4, for example, then this would be a true equation. Either way, it's still an equation. How about this? Is this an equation? Yes, it's got an expression on the left, an expression on the right, and it's saying that they're equal. Do we know what x is? Not right away, but if you look at it closely, x squared equals 4. X would have to be 2, right? 2 times itself would give you 4. And there's another number that you can multiply by itself that would give you 4. But I'll leave that up to you to figure out what that number is. This is an equation. You've got a variable expression on the left, a variable expression on the right. It's still an equation. Is it true? I don't know. It depends on what x is. But this is an equation regardless of whether or not it's true. Okay? This is an equation. You have an expression on the left, a fraction with a variable in it, and you have an expression on the right. Is it true? I don't know. It depends on what x is, but it's definitely an equation. Okay? So when you try to figure out the number for x that makes these things true, like these equations here, you are solving the equation. Okay? When you simplify something like 2 plus 4 and say that 2 plus 4 is 6, like if there was no equal sign and it was just like, hey, simplify this, you would say, hey, that's 6. You're not solving, you're just simplifying. Okay? So that's the difference there. So let's flip over to the back page here. It says, when you solve an equation, you are finding a value for the variable that makes the equation true. Okay? So when you figure out the value of the variable that makes the equation true, that thing, that number that makes it true, that's called a solution. Okay? So we're going to look at some examples here. So they want you on this one to solve the equation for x. Okay? So apparently, if you double some number, which we don't know what the number is right now, and then you add 4 to it, you get 14. So they want you to figure out the number that should go where the x is that would actually make this true. Okay, so, and what you're going to do here is you're going to manipulate this to solve for x. And you've talked about this a little bit, supposedly, in pre-algebra or Math 8. And often what you want to do is you want to subtract 4 on both sides because you're just trying to get this x here by itself. So you're trying to undo whatever's being done on this side of the equation so that the plus 4 will go away. The only way to get the plus 4 to go away is to actually subtract 4 from both sides. And now 4 minus 4 is just 0. So on the left side, you're left with 2x. On the right side, you're left with 10, right? 14 minus 4 is 10, okay? So if 2x is 10 then this is a little easier to solve, but x has to be 5. The way that you would solve this with algebra is you would divide both sides by 2. Okay, we're dividing both sides by 2 here because we're trying to get rid of this 2 here that's currently multiplying the x. So you want to undo whatever is being done. Right now it's 2 times x, so if we divide by 2, 2 divided by 2 is just 1. So we basically just kind of cross it out. 1x is the same thing as x, and then 10 divided by 2 is 5. Okay, so we say our solution then, and we put these little curly brackets here, is we say x has to be 5. In order for this equation, this original equation to be true, x has to be 5. That is the only number that you can plug in for x, put in where the x is, that would make this true. And if you don't believe me, try another number for x. Like try 8, right? 2 times 8 plus 4. That would be 16 plus 4 would be 20. Is 20 14? Last time I checked, no. That's dumb. Okay? And there's a little note here. See how we didn't follow PEMDAS? We subtracted first, then we did division. The reason for that is because we aren't super concerned about PEMDAS when we're solving. Okay? When you are simplifying, you have to follow PEMDAS, the order of operations. PEMDAS, right? Please excuse my dear Aunt Sally. Like, you have to follow the order of operations when simplifying. When solving, you can do whatever you want in order to get that x by itself, as long as you're not violating any other, mathematical rules, which we'll talk about those more as we move on. Okay, so I'm going to erase this PEMDAS here. Let's look at example 2 now. Okay, so example 2, solve for x. So it says 3x minus 5 is equal to 16. So again, what we're doing is we're trying to find a number that when we plug it in where the x is, it makes this equation true, because this equation here is a statement that this, whatever this number is over here, is equal to 16. Okay, so the way we're going to do this is we're going to add 5 to both sides. I'm going to do the opposite of subtraction. So I get 3x plus 0, right? Negative 5 plus 5 is 0. So honestly, I just cross these out because it's 0. I don't really care much about it. 16 plus 5 is 21. And now we know that 3 times some unknown number is 21. And you can probably figure out it's 7 in your head. But if you divide by 3 on both sides, that'll become very clear, right? So 3x divided by 3 is just 1x, right? If you have 3 of something and you divide it by 3, you just have 1 of that thing. So you have 1x, I'm not going to bother putting the 1, is equal to 21 divided by 3 is 7. So in our curly brackets here, we say x is 7. That is apparently the only number in the world, 7, that if you actually put it in where the x is here on this original equation, and you did 3 times 7 minus 5, it would give you 16. Okay, let's look at example 3. Example 3 says solve for x. X plus 2 divided by 4 is 3. So you have to find a number here that when you add 2 to it and then you divide that result by 4, you get 3. So the easiest way to do these when you're solving is to multiply by 4. Why are we multiplying by 4? What's going to happen here is when you multiply by 4, see how it's dividing by 4 here? You always want to kind of undo what's happening here. So you want to multiply in order to undo the division by 4 here. What happens then is the 4 divided by 4 is just 1. So we just basically cross them out, because what you have here is you have 1 times x plus 2, and it's really pointless to write the 1. So what we say here is we just say, hey, all we're left with over here is x plus 2. And on the right side, 3 times 4 is 12. And let me say a little note here. Some people want to subtract 2 first, but you got to be really careful here. Subtracting 2 doesn't work on the left side because you're dividing by 4 here. So you always want to take care of the division on large fractions like this first. So you want to multiply first, then subtract the 2. Okay? So we'll subtract 2 from both sides because our goal here is to get this x alone, and it's not alone because it's getting 2 added to it right now. So what you have now is you have x is equal to 10. Okay, so 10. So apparently 10 is the only number that if you put it in where this x was and you did 10 plus 2, which would be 12, divided by 4, you would get 3. Okay, so that's the solution there. We'll do a few more examples and then we'll be all done here. Okay, I'm just going to show you some different examples. You're going to run into a lot of stuff here. So you remember on the last problem I told you to be really careful and not subtract first. Make sure you take care of the division first. This scenario is a little different for example 4. Okay, so for example 4, we are going to actually add 4 to this first. And the reason for that is because if you multiply by 3 to get rid of the 3, you just need to make sure you multiply everything on the left side by 3. And you can do that. Some people do that. You just need to make sure you distribute the 3 so that this becomes minus 12. Okay? I like to just add 4 to start with because I feel like it makes the problem a little less messy. So on the left side, we have x over 3, x divided by 3. Minus 4 plus 4 is just 0. You can write plus 0 here if you want, but it's kind of pointless, so I don't bother doing that. 2 plus 4 is 6. So now we have an unknown number, and when we divide that number by 3, we get 6. So what we're going to do now is we're going to multiply both sides by 3 to undo the division, right? So dividing by 3 means we're doing division, and so in order to undo the division there, get rid of it, we're going to multiply by 3. Okay, so what do we have left here? We have x on the left, and on the right we have 6 times 3 is 18. Okay, so we say that our solution in this scenario is 18. Okay, 18 is the only number that you could put in here that would make this entire thing true. All right, how about this one? Solve for x. So this one's a little interesting because you have x's on both sides. So generally what I tend to do is I like to get all the x's on one side of the equation and then everything else on the other side. So if you look here, you already have the number 8 here, and then you have some variable expressions like 5x and 3x. So I think it makes sense to get all of the x's to the left side. So that means this 3x over here on the right side needs to go. How do we get rid of a 3x? Currently it's being added to 8, so let's subtract it on both sides of the equation. So you're left with 5x minus 3x, that would be 2x's, right? If you have 5 of something and take away 3 of that same thing, you have 2 of that thing, equals, and then the only thing left over here on the right side is 8. Okay, in order to solve for x here, it's 2 times x, so we're going to divide by 2 on both sides. And when you do that, the 2 divided by 2 is 1, and so you're left with x is equal to 8 divided by 2 is 4. So your solution in this scenario would be x is 4. Okay, let's do this one here. So this is basically the same as last one, except we do have the added complexity of we now have variables and numbers on both sides. So this is just me personally. If I have a 7x and a 4x, I like to have my x on the left side of the equal sign if possible. So I'm going to subtract 4x from both sides. If you would like to, if it makes it easier for you, you know we're going to be adding 2 to both sides at some point to get rid of the minus 2. You're welcome to do it all in one step. So let's add 2 to both sides here. We're going to do this all in one step. So on the left side of the equation, and some teachers will actually have you draw like a line here, like for the equal sign. I don't do that, but you can do it if you want. Not wrong. Okay, so 7x minus 4x would be 3x here. And then negative 2 plus 2 is 0, so I'm just going to leave that there. 4x minus 4x is 0. And then 16 plus 2 would give me 18 over here. So what we've done is we've essentially gotten all of the x's on the left side and all of the numbers on the right side. And what do we do from here? Well, we divide both sides. Since it's 3 times x, we divide by 3 to undo that multiplication. And basically we're left with x is equal to 6. 18 divided by 3 is 6. So we say x is 6 in this scenario. All right, we're almost done here. How about example 7? So example 7 just adds the complexity of, we got some multiplication we need to do here first. So we are going to simplify the left expression first, okay? So there is an expression over here that I would like to simplify before I kind of finish solving this, okay? So I'm going to distribute the 2 here. And you don't have to do it this way. There's a lot of different ways you can solve an equation, but I prefer to distribute on the left side. Okay, so 2x plus 8, I did 2 times x, 2 times 4, and then I'm just going to rewrite everything. I'm not really changing it, the minus 3 or the negative 9. Now what I'm going to do is actually have 2 different numbers over here, 8 and 3, 2 constant terms. So I'm going to actually simplify those into 5, right? 8 minus 3 is 5, so I have 2x plus 5 is equal to negative 9. And then from here, now I'm going to solve, okay? I mean, I've been solving the whole time, but I've just been simplifying to kind of get us to a point where it's easier to solve here. So on this one, I would subtract 5 first. So whenever you have an expression like this, like something multiplying x and then you're adding or maybe subtracting here, I always like to take care of this number first, then divide by 2. If you divide by 2, you have to divide this by 2. Like if you start by dividing by 2, you have to divide that by 2, and then you get these really awful fractions. So let's not do that. Okay, so we have 2x is equal to negative 9 minus 5. That would be negative 14. And then from here, if we divide both sides by 2, we get x equals negative 7. So that would be our solution. X equals negative 7. Okay, all right, that's example 7. All right, I think our last example here, example 8. So wants us to solve for x. Again, I like to distribute. So I'm going to distribute to both of these here. So I'm going to get 4x minus 8. And then on this side, I'm going to get 2x plus 8. And again, I like to have all my x's on the left side. So I'm going to work to get rid of this 2x here. And I like to have all my constants, things without a variable, like a letter with them, like negative 8. I'm going to try to get all my constants over to this side. So I'm going to do everything on this in the same step here. I'm going to subtract 2x from both sides. That's going to get rid of this 2x. And then I'm going to add 8 to both sides. And the reason I'm adding 8 is to get this negative 8 out of the left side. Okay? All right, so when we do that, what do we have? We have 4x minus 2x is 2x. Negative 8 plus 8 is 0. 2x minus 2x is 0, and then 8 plus 8 is 16. Okay, so really what we have now is 2x is 16. And so what do we do from here? We divide by 2 on both sides. We're trying to get the x alone. When you divide by 2 on the left side, you're just left with x, and then on the right side, you're left with 8. 16 divided by 2 is 8. So our solution here is x is equal to 8. And what does that mean? That means there's only one number that you could plug in for x that would make this statement true. That, 4 times whatever this number is minus 2 is actually equal to 2 times this number plus 4. And you can check, right? You can check. You can say, hey, 4 times some number minus 2 is equal to 2 times some number plus 4. And what you can do is you can check and say, hey, if I actually plug in an 8 here, is this true? Like, you can actually literally ask yourself, like, hey, put a question mark over this. Is this true? So let's do it. Is 4 times, so 8 minus 2 is 6. So this is basically saying, hey, I think 4 times 6 is actually equal to 2 times 8 plus 4 is 12. So is 4 times 6, 24, actually equal to 2 times 12? It is, right? So we put a little check there to say, hey, those actually are equal. Okay, so that's how you solve equations. Okay, so remember, you solve equations, and what it means to solve is you're finding a solution, a number for x that when you plug it in, makes the original equation true. Okay, an equation is a statement that two expressions are equal to each other in value. So the number over here is equal to the number over here. Okay, and then you simplify expressions. So simplifying an expression would be like what we did here, right? 2 times x plus 4 minus 3. We simplified that to this. We simplified it to here. Now we're kind of ready to solve the equation. Okay? All right. Hopefully that helps.